Cold exposure doesn't just make you shiver. It activates a specialized fat in your body, brown adipose tissue, which then aggressively incinerates stored white fat cells, turning them into pure heat. This isn't some metabolic trick or passing fad. It's a fundamental biological mechanism deeply embedded in our cellular blueprint, capable of reprogramming your body's energy expenditure and offering a powerful, often overlooked pathway to profound metabolic health. It's literally the cellular furnace turning up the heat on unwanted energy reserves. For most of human history, fat was simply fat, a soft, squishy energy storage system we mostly wanted less of. We pictured it as this inert, yellowish cushion, white adipose tissue, or WAT, packed with triglycerides, waiting patiently to be used or, more often, to accumulate. But hidden within that conventional understanding was a revolutionary secret, a distinctly different type of fat, aptly named brown adipose tissue, or BAT. Imagine two types of workers in a factory. White fat diligently stockpiles all the raw materials, securing them away in massive warehouses. Brown fat? It's the worker constantly stoking a furnace, burning those very materials to generate intense heat. For a long time, scientists thought this brown fat was primarily found only in babies, keeping them warm in their most vulnerable stage. The prevailing wisdom was that adults had very little, if any, functional brown fat. It was seen as a vestigial organ, an evolutionary relic. But what if that wisdom was fundamentally flawed? What if adults harbored this internal furnace, just waiting for the right signal to ignite? A quiet revolution in metabolic science began when imaging technologies, like PET scans, started revealing pockets of metabolically active brown fat in surprising places within adults, around the neck, collarbones, and spine. Suddenly, this baby fat was making a dramatic comeback on the adult stage, prompting a critical question: how do we switch it on? The answer, as it turns out, is remarkably simple yet profound: cold. When your body senses a drop in temperature, it doesn't just passively shiver. That's merely the superficial response. Deep within, a complex symphony of cellular signals begins. Your sympathetic nervous system, the very same system that triggers your fight or flight response, goes into overdrive. It releases norepinephrine, a neurotransmitter that acts like a cellular alarm, directly targeting those brown fat cells. It's the call to action, rousing them from their slumber, preparing them for their ultimate purpose: heat generation. But how exactly does a specialized fat cell conjure heat out of stored energy? This is where the cellular blueprint truly shines, and where a unique protein becomes the undisputed star: uncoupling protein 1, or UCP1. Unlike white fat cells, which have very few mitochondria, brown fat cells are absolutely packed with them. They're dense, power-generating factories. Normally, mitochondria produce ATP, the energy currency of the cell, by efficiently coupling nutrient breakdown with ATP synthesis. UCP1, however, throws a wrench into this elegant machinery. It acts as a proton channel, essentially uncoupling the process. Instead of capturing energy in ATP, it allows protons to flow back across the mitochondrial membrane, dissipating that energy directly as heat. It's like diverting the water from a turbine directly back into the river, bypassing the power generator entirely. But in this case, the waste product is warmth. This uncoupled thermogenesis is incredibly efficient, a biological marvel designed for survival. It means brown fat can burn calories at an astonishing rate without needing to perform mechanical work, like shivering. While shivering uses muscle contractions to generate heat, it's energetically expensive and physically taxing. Brown fat offers a silent, sustained internal warming mechanism, a kind of internal heating system that requires only the raw fuel of white fat. Think of it as a highly specialized, always-on internal combustion engine burning fuel not for movement, but solely for warmth. The implications stretch far beyond simply staying warm. This metabolic magic has a ripple effect throughout the entire body. When brown fat is activated, it doesn't just burn its own internal fuel, it begins to pull from the body's general energy reserves. It voraciously consumes glucose and lipids from the bloodstream, effectively lowering blood sugar levels and improving insulin sensitivity. For someone struggling with metabolic syndrome or type 2 diabetes, this isn't just an interesting side note, it's a potential game changer. It's as if you have an extra organ dedicated to vacuuming up excess sugar and fat from your system, preventing them from wreaking havoc elsewhere. So the obvious question arises, how do we activate this internal fire? The answer, perhaps counterintuitively, lies in controlled discomfort. Cold showers, ice baths, cold plunges, or even simply exposing yourself to cooler ambient temperatures regularly can all act as potent triggers. The goal isn't to freeze yourself, but to stimulate that mild, consistent cold stress that signals your body to wake up its brown fat. It's about giving your body the environmental cues it evolved with, cues that tell it to be metabolically resilient and adaptable. But how much cold is enough? Is there a perfect dose? Scientists are still refining the precise protocols, but the general consensus points towards consistency over extreme intensity. Short, regular exposures, perhaps just a few minutes in a cold shower each day, seem to be more effective for long-term brown fat activation than infrequent, agonizing ice baths. Your body slowly adapts, not by becoming immune to the cold, but by becoming better at generating its own heat, often through increased brown fat activity and density. It's a process of biological acclimation, where your cells literally reprogram themselves to become more efficient heat producers. Of course, not everyone responds to cold exposure in the same way. Some individuals naturally have more brown fat than others. Is it purely genetic, or can we cultivate it? Research suggests it's a fascinating interplay of both. While some genetic predispositions may exist, lifestyle factors, especially consistent cold exposure, play a crucial role in browning white fat cells, a process where white fat takes on characteristics of brown fat, or even increasing the sheer amount of existing brown fat. It means that even if you weren't born with abundant brown fat, you might be able to nudge your cellular blueprint towards greater metabolic efficiency. From an evolutionary standpoint, the presence of brown fat in humans makes perfect sense. Our ancestors didn't have heated homes or insulated clothing. Surviving harsh winters demanded a robust internal heating system. Brown fat was a critical adaptation, allowing them to conserve energy and maintain core body temperature even in freezing conditions. It's a testament to the ingenious design of our bodies, a forgotten survival mechanism now being rediscovered for its profound health benefits in our modern, often overly comfortable world. The therapeutic potential of harnessing brown fat is immense. Imagine drugs that could safely activate UCP1, mimicking the effects of cold exposure without the chill, or nutritional strategies that specifically target brown fat growth. The research is rapidly advancing, offering new hope for tackling metabolic diseases like obesity and type 2 diabetes. We are standing at the cusp of unlocking an innate metabolic power that has been dormant for too long in many of us. Ultimately, the science of cold exposure and brown fat reveals a remarkable truth about our own bodies. We are not static containers of energy. We are dynamic, adaptive organisms, equipped with an intricate cellular blueprint designed for resilience. By simply reintroducing a natural stressor, the cold, we can tap into ancient pathways that optimize our metabolism, burn away excess fat, and enhance our overall health, not through deprivation, but through activation. It's a powerful reminder that sometimes the greatest leaps forward in health come from looking back at the fundamental, unassailable wisdom embedded within our very cells.